name is Samha Al-Biltagi. I'm a professor of computer science. I obtained my bachelor's and master's degrees from the American University in Cairo. And then I obtained my PhD from the University of Southampton in the UK under the supervision of Professor Wendy Hall. That was around 20 years ago. And ever since then, I've been working on the general area of natural language processing and text mining. I actually established a research group for text mining at Nile University. And but the focus of most of my work was in Arabic. So, and this is what I'm going to be talking about today. I'm going to try to keep it simple because I do realize that not all the audience are familiar with the area. So I'm going to try to make it hopefully interesting and just go over the main topics, starting with defining what NLP is. So natural language processing is the discipline that deals with natural language. And natural language, as everyone knows, is the way that we human beings interact with one another. And it is what preserves our knowledge and thoughts. Spoken language specifically is I mean, the entire civilization would not exist without preserving our knowledge using forms of written or written language. So the idea that it's very easy for us human beings, most of the time it's easy for us to communicate and understand each other, but it has been a long life, it's been since even before computers appeared or were invented, you would find works that would actually talk about machines that would be able to understand language and manipulate it. So this has been something that has been in the ether, as they say, for a very long time. So if we want to formally define natural language processing, we can say that it's a subfield of linguistics, computer science, information engineering, and artificial intelligence that is concerned with interactions between computers and human natural languages. In particular, it's concerned about how programs and or computers process and analyze large amounts of natural language data. And this definition was obtained from Wikipedia. By definition, natural language processing is an interdisciplinary field. It draws from many or multiple fields. And if we talk about the common applications of NLP, I think that all of us use NLP in our daily lives. There are so many applications. Examples include digital assistants, such as Siri on Apple iOS, or Apple phones, Google Now on Android phones, Cortana on Microsoft-based machines. And these are also known as conversational agents, intelligent dialogue systems, chatbots. All of those are alternate names for digital assistants. The dictation feature that is found in most messaging applications that we use, something like WhatsApp or even the simple text messaging, you'll find that there's this icon at the bottom. You can actually dictate what you want to write, and it's going to be converted from speech to text. There's also another feature that's called predictive text and autocorrect. I know that a lot of people suffer from the autocorrect feature because sometimes they end up, it just autocorrects and you end up saying things that were not meant to be said. So I think that a lot of this is not one of the best features, but it's nice when it works properly, but it's really frustrating when it doesn't. So autocorrection is also one of the, and of course, predictive text. And predictive text is this feature here when you're typing something and you get suggestions as to what you would like to input instead of writing it, writing the entire text out. You could just press the button and it's a shortcut. It saves a lot of time. Spelling error detection and grammar checking, online machine translation applications such as Google Translate. And these are just, this is just a sample of programs that we all use on a daily basis. But there are many applications of NLP. I'm not going to go through the entire list, but OCR is perhaps one of the really important ones. If you're working in the field of education, then plagiarism detection, spam filtering is something that happens automatically in most mail programs. There's a question answering. There are so many things, and I don't want to waste your time by going through the entire list, but the applications are simply endless. So this is NLP in general. So what are the challenges of the Arabic language? Arabic is I think that most of the participants now, I can see that most of them are probably Arabic speaking, but Arabic in general is a rich morphological language which has something that we refer to as a rich inflectional system. A rich inflectional system means that we can add all kinds of clitics, or at the beginning, at the end, or in the middle, and that usually makes for some complicated words. A single Arabic word such as بأيديهم, when translated into English, would typically map into a number of words, not just one word. So something like بأيديهم, I've actually typed this in Google Translate and it would translate into with their own hands. So this is 4 words. There are other examples when you can have up to 5 or even 6 words, just in using a single representation. The Arabic language is also inherently ambiguous. So because it uses a lot of diacritics in order to indicate how a word can be pronounced. There's a very, very high degree of ambiguity. So if we take a word like these 3 letters, عقد or عقد, and if we start pronouncing them differently, they could mean many different things. So this could be عقد, 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 which means necklace, عقد, which means contract, عقد, which means complicated things, عقد, which means a decade, عقد, which means performed, عقد, which means knots, among other things. So the context plays a really, really important role in understanding what a word means, and sometimes even that doesn't always help. It has no casing. In English, we have capital letters, and this usually makes, when we're trying to identify the names of organizations or people, this makes it simpler in named entity recognition, but it has no casing. And it has letters whose appearance differs depending on where they appear in the word. For example, الياء at the very end is different than if it appears in the middle. It's also different if it appears at the very beginning of the word. And this could complicate tasks such as optical character recognition. When writing Arabic, there's often also a lack of uniformity when representing foreign names. So depending on who's writing, something like Washington could be represented using multiple forms. The waw, which is the and, which represents an and or a conjunction particle, is often attached to other words. وذلك, وذهب, وقال, and it's not always clear when we should segment this word. I mean, it takes a lot of work. It is doable, but it's not that simple. Dialectical Arabic, which has become very commonplace right now, uses idioms, Quranic verses, and expressions derived from popular culture to express opinions, which can often complicate sentiment analysis as well as machine translation. So, for example, you can find you can find an expression like "لا يا شيخ حسبي الله ونعم الوكيل" to indicate that someone is upset about something. يقتل القتيل ويمشي في جنازته to criticize the behavior of a person. انسى يا عمرو, this is actually derived from popular culture, and expressions like that are derived from popular culture appear all the time, especially in Egypt, I think. So this really complicates any system that is working on dialectical Arabic. Dialectical Arabic itself differs very different. It differs greatly from one Arabic-speaking country to another. So Egyptian dialect, for example, is very different than any other dialect spoken in all other Arabic countries. So these are some of the challenges. These are not all of the challenges. I've just highlighted some of the challenges related to Arabic NLP. So if we think about the work of on Arabic NLP, we can say that early work in this area more or less targeted text written in modern standard Arabic. Modern standard Arabic is simply the formal representation of Arabic. It's what we find in newspapers, or if someone is actually reading a news bulletin, they use it's not the Quranic Arabic, but it's the formal one. However, the dramatic increase of textual content caused primarily by the usage of social media has resulted in more and more research being directed towards dialectical Arabic. Because when people are writing text in social media, they're actually writing it as if they're using the way that they would actually otherwise speak in general. Until quite recently, resources for Arabic NLP were quite limited, and Arabic was considered as a resource poor language. We can still argue that this is still the case, but the last 10 years have witnessed a lot of research in the area, and more resources are being availed by the community for public usage. Okay, one of the recent developments, and I think this has impacted not only natural language processing, but also anyone working on speech or images. This is deep learning. Deep learning has had a great impact on NLP. And specifically, it has increased performance in tasks such as named entity recognition, part of speech tagging, sentiment analysis, machine translation, and question answering. And one of the major byproducts of using deep learning models was the creation of alternate word representations that are semantically rich, and these are being now more and more used instead of the traditional bag of words model. Okay, I think I only have 6 minutes, so I'm not going to talk about.
Please.
Yes, I'm not going to talk about.
Thank you.
I'm going to skip a few details. Okay, and I'm going to skip the bag of words model, and okay, I'm just going to talk about the rich representations that were brought forth by deep learning models. So this idea of word embeddings is one of the really major ideas that came with deep learning. I know that a lot of people are not familiar with how words are represented in a natural language processing system, but usually we had a vector that was really sparse. That's the bag of words model. But the word embeddings paradigm, it's just you have a much more condensed a vector, okay, and it's not sparse, it's non-sparse, and it's a dense vector of real numbers that represent a word. And usually the way that they're built is by taking a large corpus, and the whole idea is that you end up representing a word by the company it keeps. So somehow these models, any word embedding building technique relies on the context of in which a word appears in order to derive its vector. So the result is that you actually end up with a representation that is semantically rich, and you can do all sorts of, I mean, if for example you say, the whole idea is that similar words tend to have similar embeddings or vectors. So if you query something like what are the most similar words to Egypt, you're going to get Tunisia, Turkey, Libya, and so on. Paris, you get London, France, New York, and so on and so forth. Then I'm just going to skip over a few things. Okay, then in the last couple of years, another more advanced, again, this still belongs to the this idea of embeddings, but something called contextualized embeddings appeared, and BERT was a pioneer in this. It was developed by Google, and instead of just using a huge corpus in order to represent a static set of vectors, it uses the context in order to calculate that vector. Again, it has to be trained over a huge input corpus, but the context in which a word appears plays a major part. So if we have a sentence such, I'm going online now to check my bank account, and yesterday I had a really nice picnic by the riverbank, the two vectors for bank are going to be different. Okay, of course, the problem with this is it's in terms of performance, it's much slower computationally. It's still very expensive, but these ideas have really I mean, they've actually made a serious impact on how a lot of natural language processing systems work. Because of this success on English NLP tasks, several Arabic BERT models were developed. These include Arabic BERT, AraBERT, and GigaBERT. And they've been used extensively, again, to improve a lot of systems. I mean, the task of sentiment analysis has improved greatly, dialect identification, information extraction, POS tagging, NER. I'm just going to show you an example. This is an application that was developed by one of my ex-students. He has already finished his master's, and he has done this in his free time using a deep learning model. This is an NER system. And in this example, I've actually used this system yesterday, and I wrote أنا سمحاء البلتاجي سأقدم presentation بكرة. I'm intentionally using dialect في اجتماع الأكاديميين المصريين بمصر والمملكة المتحدة. And you get here that my name has been correctly detected, that بكرة is a time, that اجتماع الأكاديميين is an event, and so on and so forth. So now I'm going to conclude, because the whole this is, I mean, we are actually in a very exciting era. We're seeing a lot of interesting work being done using this alternate word representation. There are still a lot of challenges to be addressed in Arabic, and these are some of the areas that need, I mean, a lot of attention: detecting irony and sarcasm, creating semantic similarity models, machine translation, dialectical speech recognition, code switching, especially when using Arabizi, because a lot of people use Latin words in order to express Arabic, but in order to they complicate things even further by actually using Latin words to express Arabic as well as non-Arabic, and they combine between the two. A question answering, we don't have enough data sets. Most of the contextualized embedding models that we have, the BERT-like based models, haven't been trained using sufficient dialectical data. A lot of the countries, not all of them, but a lot of countries, such as Egypt, for example, working on Arabic NLP, suffer from limited infrastructure and computational resources. And I mean that especially for students. Of course, there's the opportunities is that the importance of NLP on all fronts, education, customer service, medicine, and so on and so forth, is becoming more and more apparent. Many countries, including Egypt, are aiming to completely digitally transform, and NLP can play an important part in that. And the potential for NLP in multiple domains is endless.